Okay, good afternoon. How are you? Good? How was NDC the first day? Good? Great. So this is the last session of the day. So I'm here just to tell you that maybe you don't need that library. Okay. So we will talk about vanilla web. And my name is Maximiliano, by the way. I can go by Max. I know it's a long name. Really quickly, I'm from Argentina. So I came from Buenos Aires. That's where I live. And I'm a mobile web developer, so I have been doing web apps since forever, like 1996 HTML, JavaScript 1998. And I have published a lot of web apps, most of them, probably 85, 90% of them without any library. First, because we didn't have a library at that point, but also because even now I'm doing a lot of vanilla web apps for clients and customers. And I'm also an author on different books and courses on different topics, okay? Typically around performance, the web, like a brand new idea or project. I'm working on a vanilla web book that is coming this year. And the latest book that you can find that I author is Learn PWA, published by Google on web.dev, is free on progressive web apps. Okay? And you can find a lot of content, including a Vanilla.js workshop at Frontend Masters and other libraries. So, some questions for you. How many of you are right now creating web apps? A lot. How many of you have been creating web apps for 5 years? 10 years? 15 years? 20 years? I have like one there saying kind of, if not I'm the only one. And some of you, when you arrive here, may be thinking, oh, this is the old guy, okay, that is here to talk about GeoCities and how the web was created in the 90s. Not sure if you even know what that is. But anyway, or that I'm this old guy explaining like, hey, that old guy is talking to us, explaining how web apps were created in the 90s. So in the 90s, we were not using any libraries, blah, blah, blah. But that's not the idea, okay? Well, maybe I can quickly show you how I was doing my first web apps in 1995. This is a video I created for Fluent conferences like a couple of years ago. I didn't even, so I was using that editor, that's the edit from DOS. Actually, I couldn't, if you pay attention to the file extension, I couldn't even use 4 characters for the extension, so it was HTML, okay? And I was just writing like this, HTML, and it was actually working, to be honest. And one of the interesting parts is that if I open that same web app today, it will still work on any browser, okay? We don't have CSS, so we have to use font, big, and those things. Let me adjust the microphone. There we are. And then I was opening the file in Netscape. Of course, everything was much slower, okay, to actually see that HTML. And even it was blinking because I was using the marquee. But anyway, I'm not talking about that, about the past. This is not about the past, okay? So we're talking about the present and even the future. And at the time, the feeling was that your desktop, when you were working with your project, looked like this. But these days, when you look at the code that you are deploying to the cloud, sometimes it looks like this, okay? And maybe you can say, well, you know what? If in my desktop, it looks fine, but then we have node modules, and we have a build process that is currently sending a lot of files to the server. So we are adding a lot of complexity to the code that we are deploying to servers. And sometimes we are not really aware of how dangerous or the cost of that complexity. So how did we get here? So when I started, again, there were no idea of a library for the web. Then we started having issues between browsers. I mean, the browsers were Internet Explorer versus Netscape, and compatibility was not good enough. So some libraries started to appear. Prototype, does anyone remember Prototype? Then, of course, jQuery. Maybe you have heard about jQuery. It's still the most used library on the web these days. And after that, we came with Angular.js, the first one, then React, then Angular, the good one, okay, the Angular 2. And then the rest. Okay, Next.js, blah, 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 blah. And every time there is a new library, you come to conferences and you hear about new ideas and new libraries, and we are always getting the same promise. Okay, until this is still happening. You were all happy with Next.js, let's say Next.js, but now you read an article or a session saying, no, no, now you need to go with Remix or Astro or wherever. So I've seen this over these decades many times. Okay, and sometimes we forget why we're doing what we're doing. So that leads to the idea of thinking about vanilla web. So let me get into that. Maybe you're thinking, but I love React or Angular or Vue or wherever. You need to remember these are just tools. Tools, okay? And what happens when you only have a hammer? Everything looks like a nail. So there is today, I'm not saying it's your case, but there is maybe 1 or 2 generations of web developers that they learned just with the library. So they don't know anything else than Angular or React. So that means that they think everything is a nail because that's the only thing I know. That's my only tool. Everything is going to be solved with a hammer, with Angular. Okay, and the thing is that I want you to also love vanilla JavaScript, to think on vanilla JavaScript just as another tool. And maybe some of you are thinking, yeah, but that's like writing in assembler, like going back to the past. Actually, that's not true. Okay, I will try to show you some examples so you can realize it's not true. So we are not actually going so low. It's not really low level. We just need to use modern APIs and abilities that we have in the browser. So let's define vanilla JavaScript in case you were here without even knowing what that is, and that leads to vanilla web. It's the usage of the core language and browser APIs to create web apps without any additional libraries or frameworks added on top. So it's just opening VS Code, creating a folder, and creating an HTML, a CSS, and a JavaScript files, and work with that. Of course, you can add more files and so on. You can use design patterns, architectural design patterns, and even you can use build tools if you want. But it's not like starting from scratch saying, oh, no, I will use React or Next.js or Astro. So let's think about the problem and see if you need that. And vanilla JavaScript, the term, has been a concept for a decade now. But actually, before that, it was just web apps, JavaScript. Okay, so we were building web apps directly with the web technologies. Now, the standard is to always create web apps with a library. So that's why we have to name this as vanilla JavaScript. And by the way, why vanilla? In case you haven't heard about that, is because of ice cream. So Italian gelato, the vanilla ice cream is the one that is like the base ice cream for the rest. So it's like an ice cream without any particular flavor. That's why every time you see vanilla used in software development, vanilla core, vanilla wherever, means it's that particular thing without anything on top. So vanilla web means using the web technologies without anything else on top. So I will try to give you like a quick overview of where we are and what are the possibilities that you have with vanilla web today that sometimes you think, oh, but that's a React ability, or that's an Angular powerful feature. And actually, no, it's a browser feature that, of course, Angular is using, but also you can use that feature without Angular. So Ben Holmes on Twitter said this, that every front-end developer should build their own framework at some point, because using that taught him more JavaScript and web APIs in a month than years of React ever did. Like web components, modules, using JavaScript directly, and so on. Why do we need to care about this? I already mentioned to add one more tool to your toolbox. I'm not here to advocate against the usage of libraries. I'm here against the usage of libraries because that's the only thing you know. And you think that you can only solve problems with libraries. So also, it will help you understand your library. So it will make you a better developer in your current library, which also let you extend your library. So sometimes you have a problem and you are, well, I would say Googling, now you are ChatGPT or using Cursor or wherever and ask AI to solve. I don't know, I have a video player with React using 3 plugins that I've downloaded from somewhere. I need to do something special with that video player, and I'm trying to figure out how to do that. I add more dependencies. It's not working, and maybe it's just one line of JavaScript that you need to understand that you can get out of your library for a minute because the video player is from the browser, not from the library. And maybe it's just one line of JavaScript. So you need to stop being afraid of getting out of that. So to be a better web developer, so you will definitely be a better web developer if you know how to do things without libraries, and also to mix it with libraries, because you can mix. Some parts will be in your favorite libraries, but some parts don't need to do that, so then it's just vanilla web, and maybe one part, one snippet, one section of your website is actually a mini web app written with a library because you think it's the right tool for that particular part. So to use it. Main advantages of vanilla JavaScript: lightweight, high performance. This is one of the most important ones. Many of the most high performance websites out there are just plain web technologies. Control and power. You have full control and power of what you're doing. That's also a challenge. Simplicity. Okay, you are not adding a lot of complexity. You don't have hundreds of dependencies that you maybe understand one or two, and on the rest you don't know what's going on there, and that will be part of your code base. Flexibility, and yeah, half joke, but half reality, no node modules. So you are in control and you know exactly what you're shipping, what code is currently being shipped to your web app. That adds security, okay, and many things there apart from performance. Main fears, because I know not everything is initially really, really good. And I've seen this list of fears on Twitter, so I did like a survey on X about the main fears. For some reason, the first one, top one, is client-side routing. Like the ability to change between pages or views in a single page application sounds really scary if I don't have a tool like Angular Router or React Router that will help me with that. Then, but it's too verbose. Okay, the state management is difficult. Templating is difficult. That we cannot like define reusable components, or it's not compatible with every browser, or it's complicated. That the learning curve is really high, which is actually interesting to see that after you had to learn one specific library and all their internal design patterns and way of working with that, and that you are reinventing the wheel on every project. Okay, those are the main fears. So we will go now through the current state of a lot of situations, and then we will go back to the list and see where we are. So again, I'm not going to advocate for using vanilla JavaScript on every project. Okay, it depends on the project if it's the right tool or not. So if you feel like you are reinventing React, yeah, it doesn't make any sense. The thing is that when you use React, because it's the only thing you know, and now I'm not sure if you try that, but the hello world in React now has more than 20 files. Okay, yeah, and you say, well, but you shouldn't be using React for a hello world. Well, that's the point. The problem is that there are a lot of developers creating just a calculator in React. So even asking AI, you are using AI to create apps, and you are saying, using React, create a calculator for me. Why you are adding complexity? Even with AI, you are moving your complexity to the AI solution that doesn't need that tool. So also, when we are doing vanilla JavaScript, we can still use micro libraries for specific purposes. This is not for just, I don't want any library. It's not about that. It's about, okay, if you need a state management and you really like Redux, let's say you like Redux, you can use Redux. If you like a router system, you can use router micro libraries that maybe is 2K of JavaScript, and that's something you add, and that's all. it's fine. There are many micro libraries that you can use, and you can create your own as well, so you don't reinvent the wheel every time. So this is an example. At the end of the session, you have the URL. If you want to see it, it's open source. It's part of my workshops on vanilla JavaScript. It's just an app that it's targeting mobile devices, but it has nice animation, transitions. You can add things to a cart, and everything is using also reactive programming. So if the cart is changing, that icon at the top, that badge, is changing automatically. And it's also a PWA, a progressive web app. So you can install it, and then it looks like a native app in Android, desktop, iOS, and so on. Okay. So to make those apps, you need to start with semantic HTML and vanilla CSS. I know, no, I will create a project and I will start with Tailwind or Bootstrap. Well, I mean, you can if you feel it will help you, but first, try to do it without it. And you will see that it's not like in the 90s or in the 2000s. We are better now. So semantic HTML is just using the right HTML tag for everything. This will also, but this is a parenthesis, this will help you in AI discoverability as well. So let me give you a really, really quick message. So last week, I went to my dentist in Buenos Aires. You should go to your dentist every once in a while. And he told me, you know what? This month, I've got a lot of new patients, and they were all coming recommended by ChatGPT. So users are searching for dentists in ChatGPT, and whoever appears there is winning those new customers, patients. Okay, and so you have to now optimize your content for AI apps. And one of the things is that it's better if you have your semantic HTML. You're using your H1, H2, the table of content is clear. It's not like 1,000 divs that you have in your system with a dozen CSS classes on each div. That's kind of the average app that you get when you're using some of these libraries. Everything is a div. There are nested divs to the infinite with dozens of classes that are defining the style. That if you read that, you as a human or the AI that is reading your HTML, it takes more time and processing to actually get the right tokens and make the semantic relationship with the data. So keep your HTML semantic and go with vanilla CSS. Today, there are a lot of things you can do with CSS that maybe you haven't heard of, such as you can create variables in CSS. For example, for your color palette that then you reuse over your CSS. You can create functions in CSS as well. You can use container queries that are a way to contain how everything looks like in small parts. Also now, we have a concept known as web UI. I'm not sure how many of you have seen yesterday, really late. I stayed awake because of jet lag, but also because it was Google I/O. And there were some sessions at 2 a.m. here. And they were actually, and this is a slide I added yesterday at 2 a.m., they added a lot of things that Chrome, but not just Chrome, all the browsers. Chrome is the first one, but they're pushing this to all the browsers with the conversations with all the browsers to improve web UI. And that's the ability that, for example, to create transitions. This is actually now available on every browser, so it's not for the future. This is the ability to transition between one state and the other, talking about the UI here, and animate that transition without you manually, with JavaScript, explaining or saying something like, oh, I want to change that property from 0 to 1 opacity, from 0. No. I have one state, another state, and I will talk to the browser and say, hey, browser, I just want to animate those states. What's the state? You change something in the DOM, and that's all. Customizable selects. So now a drop-down can be customized as much as you can. just with HTML and CSS, no JavaScript, no libraries. So you can create a nice picker with flags and images inside, animations in each options that the user is selecting, and it works on every platform. Customizable scrolls, this is pretty cool. Coming to Chrome, you can create carousels without JavaScript now. In 3D, with everything you think about a carousel, just with CSS. There will be no JavaScript at all, no dependencies. And new specs are coming. The idea is to let us customize the whole user interface just with CSS. So then we know we can create a calendar. We can create a lot of like native components that maybe we have that component, but we don't like how they look like in the browser. And so the way to solve that is to use a library that will be a JavaScript library or a React plugin or whatever that is doing a lot of weird stuff there. Well, we are moving back to let's just use CSS, okay, for that. I'm not sure if you have seen this website, just usehtml.com, okay? You can check it later. There are several translations. I'm not sure if there is a Norwegian translation. It's kind of a humor website, but anyway, it has a message there. When you read the whole, it's really large, okay? Like, just use HTML, remember it's there, okay? Also, we also need to know that these days we have a lot of static generators that not everyone is actually looking into that. Sometimes we're creating websites or even some kind of web apps, even e-commerce web apps, that they don't need to be single-page applications. So, but maybe you say, yeah, but I want to have components, and so I want to use my own design patterns. I don't want to write 1,000 HTMLs, one per product. Yeah, I get it. But we do have static generators. For example, my own website, Firt.dev, is using a static generator, so it has courses, articles. It's getting 98 in performance in Lighthouse because it's using a static generator. I'm using Eleventy. I'm not sure if you have heard about it. There are many static generators for many libraries. In this case, you will generate your HTMLs in your development environment. So you have a build process. So you have something that looks like a server-side application. But then when you build your app before deploying, you get just static HTML files from that build. And you publish just static HTML files. So then you don't need a lot server-side. You're not going to pay a lot of cloud bills because you don't execute a lot. Maybe, of course, you may have a cart, a shopping cart within that e-commerce website. But let's go back to something that we were doing like 20 years ago. They just generate the static HTMLs. And what happens if you have a change? You generate HTMLs again, and you publish the new version anyway. But we will have some moments and apps where we actually need client-side routing. Again, the main #1 fear of using vanilla JavaScript. Well, actually, this is pretty simple. It's not really complicated. So you're in one page, section 1, you want to click section 2, and you want to change the contents of that, and section 3. So in vanilla JavaScript, it's just a couple of JavaScript lines. It's not really a big deal, to be honest. But I don't know why people are so afraid of that. There are two ways to do this. It depends on how complex your app is. You can remove the previous page and inject a new page into the DOM when you are changing pages. When you're in the home page, you want to go to About Us. Well, you remove the home page from the DOM, and you inject the other one in the DOM. But if your page is simple enough, you can just have all your pages in the DOM, and you are just hiding and showing different parts of the page. Again, try to create an app with bytecoding and request vanilla JavaScript. And the AI will actually do this, and it will be really fast. So for example, really simple. So 3 sections. You have section 1, you click on section 2, so you remove section 1 from the DOM, and you put section 2. That's all, pretty simple, 3 lines of JavaScript. And if you want to show and hide, you, for example, you just change the hidden property. We don't have a Boolean hidden property. So I don't need to think about reflow. You just change the Boolean property. So dot hidden equals true, dot hidden equals false, and it will work. So I don't need to think about, oh, I need a state variable to know. No. Okay, it's actually pretty simple. You just change who is hidden and who is not. So, but you say, oh, but it's not going to be animated. Well, yeah, with transitions. I ask the browser to create the transition between these two states, and it will create a transition. There are many transitions that you can define using just CSS. So we just want to change the content. For example, in our page, the page you saw on the coffee store, you have a home page, details of one particular product, or the order. 3 pages, nothing really complicated. So you may have multiple HTML files, but also you can just share everything in one HTML. But you say, no, but I like Angular. I like, for example, the idea of having a template in a different HTML file. You can do that. If you want, you can do that. It's not really complicated. Again, one line of JavaScript. There are 2 APIs that you can use to actually manage the browser gestures, because the user can go back and forward using the back and forward buttons in the browser, this side, or using gestures. I mean, from your phone, you can go back using a gesture. Depends on the phone, the browser. Well, I want to work with that. We have a modern API that is still, let's say, 80% compatible. So it's still not in baseline. We'll get into baseline later. So we can use the old history API that has been with us since the 90s. That is actually pretty simple. You can push a new state, and that means a new URL, into the URL bar. You pass an optional state as the first argument. That's just an object that you want to pass to the other page. A second argument that is unused, so it's null. Yeah, this is from the 90s. So, and then the new URL. And if you want to listen for changes, so if the user is going back or forward, it's add event listener pop state. You get the new URL, and based on that, you show one page or the other with the switch, with regular expressions, with the code that you want. And if you feel it's too low level, again, 4 lines of JavaScript, you can use a micro library for routing if you want. But you can keep it very simple. The simplest your web app, the simplest your router. Yeah. So the other big topic, typically when we are talking about vanilla JavaScript, is about components. So when you are working with Next.js, that's React behind the scenes, or Angular or Vue, you know you have this idea of components. You know what a component is. Well, can we keep the same idea on the web without a vanilla web? Well, we do have web components. There is just a design pattern. So it's not an API, it's a design pattern, to create modular reusable building blocks for web development, encapsulating a set of functionality and user interface elements. You know what it is. So here it's a design pattern to create your own custom HTML tag element. So you can register in the browser your own custom HTML element, like a country selector. So every time you use a country selector, you have a lot of behavior there. They can fetch data from the servers or the countries, wherever. So right now, this set of APIs is compatible with every browser, so we don't have any compatibility issues. It's actually a set of standards or specs, not one. And you can use all of them together, or you can just use the one you prefer. We have custom elements, HTML templates, and Shadow DOM. So we will get with some example of each of those. And it's similar to the idea of components that you have on other libraries or frameworks. And here comes the part where we need to make a decision. So in vanilla web, because we are in charge, we are also in charge of defining our own style guidelines, our own design patterns. We don't have oh, you need to do it in this way. Okay, so you need to create your own design patterns. And if you like some design pattern from your favorite library, you can also bring those ideas into how you are developing your vanilla web app. So let's start with custom element. It's a way to define a new reusable HTML element with custom behavior and functionality using JavaScript. So this is how it looks like. You create a class, you say, oh, classes, I prefer functions to create components. Well, this is JavaScript. So JavaScript is a very flexible language. So if you want a function, you can convert the syntax into function pretty easily if you want. Okay? So it's a class extending from HTML element. That's the base class, but if you want, you can also extend from one specific HTML element, such as I want to extend list items. So then you extend from, or image items. So you extend from HTML image elements. So there are a set of classes there. So we're using OOP here. So we are extending from HTML element, and then we call custom elements.define the tag name that you want and the class. That's all, pretty simple, okay? So then you can go and use that new my element in the HTML or in JavaScript when you create elements. So now the browser knows there is a new custom element. Something important is that to be future-proof, so compatible with the future, your HTML tag, so the name of your element, must contain a hyphen. So this is, for example, if you create now a component for, I don't know, a slider. You have a slider or whatever, or double slider. So if you call it a slider that is not in the HTML this day, what happens in the future? The browsers create a new slider tag. It will collide with your custom element. So that's why we need a hyphen, and the W3C already arranged the idea that in the future, or they will never create the HTML elements with a hyphen. So if there is a hyphen in the name, it's a custom element created by the developer. So that's why it says here my element. And also you can have attributes like input properties in Angular or props in React. The only requirement here is that from the HTML point of view here at the right, they must use data dash. So that's the prefix for custom attributes. So for example, data dash language will appear in your class as this dataset language. So every data dash attribute goes to an object that is immediately available in your class. Okay, makes sense? Similar to how props work or input properties in Angular. So we also have a lifecycle available, similar to, again, other libraries. So the most common ones, apart from the constructor, is connected callback. This is actually because you are an element, when you are actually injected in a DOM, so in an actually document, that's connected callback. So you are connected to a DOM, to a real document. So there, this is kind of your own load, okay? And you can also talk about disconnected when someone is getting out. So you are getting out of the DOM. Adopted callback is when you are being moved to another document. This is a weird one, but there are some situations, iframes or other stuff, shadow DOMs as well. And attribute change callback is also the one that is useful, that will tell you when an attribute is changing. So if someone is changing the language, then you may want to re-render your contents. So that's how you realize something has changed. Okay? Cool. And also you have slots. Slots, you can have one or more than one slots, and the idea is that you can be a wrapper for more elements, like standard HTML elements or custom HTML elements, and then you can read them and do something with that. So that's one part, custom elements. Then we have the template element. A template element is a fragment of markup that can be cloned and inserted into the document at runtime with reusable HTML content that can be rendered and modified dynamically. You say, what? What are you talking about? Well, this is how it looks like. It's a template HTML element. When you do that in any HTML element compatible with every browser, nothing will happen. So the browser will not render that header. It's in the DOM, so the browser will parse it, but it's a template. It's not real content, it's a template. So it's kind of a base class. Then if we want to use it, we need to clone it to create an instance of it, but here it's cloning, that's the term. We clone it, we create another instance, and that's the one that we put on the page that will actually be rendered. Okay, make sense? So you create all your pages, for example, as templates. So they're not going to be rendered. And then the router, based on the URL, can actually say, oh, you know what? We are in the home page, so let's take the template of the home page and render it. Something like that. So for example, if you mix the custom element with templates, you can use connected callback, get the element by ID of the template, clone the element, and then append child that content, which means that's how you define your own HTML if the content of your web component is in the current document, in the index HTML. Also, you can write your own HTML as in React. By the way, you can use JSX with vanilla JavaScript. You can if you want. JSX is not only attached to React. Of course, you will need a build process. Actually, there is a client-side compiler as well, but from a performance point of view, it's a really bad idea. So, but if you have the build process, and you will really like JSX, you can use JSX with vanilla JavaScript without React. So, so when you're creating a custom element, you can use DOM APIs to actually inject the contents. You can use a template tag in the main HTML. That will be the template for that particular web component. You can have an external HTML file, as with Angular, where each component, each template can be an external HTML file, so you can simulate that behavior. And then inject it using inner HTML or DOM parser that is a little bit more secure. So, and also you can even create your own template engines using tagged literal strings. I'm not sure if you have heard about that. Tagged literal strings. It's a feature from ESX, so ECMAScript 2015. So it's been 10 years with us. And the idea is that, do you see that vanilla prefix to the string? It's not a typo. There is no missing parentheses. This is how it looks like. So that vanilla is actually a function, but a special function. It's called a tagged literal function. And it will let us parse the contents of that string. So we can actually do what you are maybe expecting from that. You can take a title and replace that $sign title with a real title variable content. Okay, so using this idea. And there are some micro libraries such as lit.html that are using this technique. So you can use template engines for your web components as well if you want to. Again, it's a decision. What about CSS? Well, several alternatives. You can use CSS APIs. I'm not sure if you have seen that. It's not my recommendation. It looks weird. But you can create CSS from JavaScript. Or you can add, actually there's a typo there, a style tag to a template. So you can add a style tag to a template, and when that template is being cloned and injected, it will download it will create the style or the link. So it will download the CSS file for that particular component. Or you can use fetch, download the CSS, and then inject that CSS in your component. Oh, it's a lot of work. I have to do that on every component. Remember, this is OOP. Remember, it's a class. So if you have a behavior that you feel it's going to be on a lot of your web components, you can create the base component with all that behavior and then extend from your base component, OOP. Okay, makes sense? So you don't need to copy and paste. You use OOP reusable features. So, and then you can have different pages or different components that maybe you define in one line. By default, this is important, the nodes of our custom elements are part of the same page's DOM. So CSS declarations applies to all the document. Let me show you an example of that. Look at that code. So I have a header with an H1. So and then I have a style saying H1 color red. When you look at that, you're expecting that header, that h1, this is a template, to be in red. And yeah, it's going to be in red. The thing is that also other h1s in the same document will be red. All the h1s in the whole document will be red. So every web component, by default, has the power to change the styles of everything in the page, which sounds scary, okay? Maybe we don't want this. Maybe it's okay, it depends on the case, but it sounds weird. So that leads to our third and last API that goes with web components, known as Shadow DOM. In this case, we create a private, isolated DOM tree within a web component. It can also be outside of a web component, but typically it's a web component that is separate from the main document's DOM tree. So, for example, if to our template we define shadow root mode, open or close, I will explain what that is in a second, then that h1 will be applied only to that h1, the h1 of that component, and not the rest of the page, which is closer, for example, on how CSS works on Angular by default. When you change h1, it only changes h1s in that particular template, in that component. The root mode can be open or closed. If it's open, it means that CSS, both CSS and JavaScript, can access, this is my web component, but I have a page here. That page has CSS and also JavaScript. So can I get into the DOM of that web component from the outside, from CSS and from JavaScript? Yes or no? If it's open, I can. If it's closed, I cannot. That's the only quick idea. I'm simplifying, but that's the idea. There are two ways to define a shadow DOM. One is declarative in the template as just an attribute, and the other one is from JavaScript. So, for example, when you create the element, you create a new DOM, shadow DOM, and that's with attach shadow. And you specify if you want it open or closed, and then you work with that idea. So with that in place, if you use these three, but again, you don't need to use the three at the same time. But when you use the three APIs, we are saying you have a web component. But sometimes maybe you want something even simpler, and you just create a custom element without Shadow DOM, without templates. So it's not like every web component or every component you create must use the three APIs. It depends on the case, what do you want. So now, as I mentioned before, that h1 will only be applied to that particular h1 and nothing else. So the other, let's say, big topic that we have with when we are doing vanilla web is reactive programming. What's the idea here? For those of you using libraries, you already know what that means, even if you don't recognize the term. The idea is that if I change the data, my UI will be updated accordingly and automatically. So that's when you have an interpolation, for example, or in JSX, or in an Angular template, you say, I want here to render the title. Then you go to JavaScript or TypeScript, you change the title, and the UI changes accordingly. Well, to do that in vanilla JavaScript, initially, it's a little verbose, but you can work with that if you want. But the idea is to keep the data synced using just the single source of truth pattern. That I have an array of content. So if I change the array, so if I add elements, if I remove elements, anyone that actually needs to know that should be called. And so it will update the data, it will send the data to the server. I don't need to remember. Every time I change the array, I need to update the UI. I need to call, update the list. The thing is that sometimes you change the array and you forgot to call update the list, so then you have a bug that is changing in memory but not in the HTML. Well, we can get rid of that problem by using reactivity. This is a design pattern. In vanilla JavaScript, there are many ways to do this. The older one, it's called a proxy. That is a little verbose, but again, you can work with that and create your own micro library or framework that makes this simpler. So for example, if you have an original object, any object, you can create a proxy on that object. So it's like a wrapper on that object. And you can even, when you're doing ECMAScript modules, you can export just the proxied object. Okay, so you're exporting the proxied object. The proxy receives the original object and a handler. The handler is an object, the one that you see at the right, with functions, hooks, if you want. So the idea is that, for example, when someone is getting or setting the property on the original object, you can do something. So for example, when you're getting the age on console log s.age, you're getting 30 years old. Even age is just a number. Why? Because we have a proxy, and that proxy is doing something on the get operation. Based on this idea, you can also change the set. So when you're setting any property of that object, you will update the UI. So if you export only the proxied object, everyone that is using the object will get updated. Everyone that is changing the object should update the UI. This is one way to do that, proxies. There are other ways to do reactivity in JavaScript. And also now we have the idea of signals. Not sure if you have heard about it. You can use a library, micro library, to use signals. And now there are some proposals to have signals directly native in JavaScript in the future. So maybe we have that natively. That will make this even simpler. Or you can use RxJS, okay, if you like it, or any other system that will let you work with this. And then we have the web apps power. Okay, I'm not sure how many of you have seen yesterday's Google I/O keynote. No one watched. Well, or even the Microsoft Build keynote. No, so you don't watch keynotes. Yeah, you don't like keynotes. You just go to YouTube and find the video saying the keynote in 5 minutes. Right? Well, on both the Microsoft Build keynote and the Google I/O keynote, they did a lot of apps with AI, of course, right? With vibe coding. I'm not sure if you realize that all the apps that everyone is showing, apps, games, everyone that is doing vibe coding, everything is a web app. They're not doing native apps. They're doing web apps and shipping those web apps immediately on the cloud. So they're building and shipping. So AI is creating a new game, and we are shipping the game on the web. So the web is actually getting more powerful because of that, because now we are realizing that, yeah, you can build an app in 2 minutes with AI. We're not going to discuss here the quality of that, but you can create an app in 2 minutes, but then you need to wait, publish the app on the App Store, and wait for Apple and Google. So it doesn't make any sense. So, we can have it up and running in 2.5 minutes if it's a web app. So that's why everyone is using a web app. So that leads again to the free kind of interactive book course that I have with Google on web.dev. Learn PWA, so I encourage you to go there and understand what you can do these days. But basically, you can make your web app installable. Maybe you know that was known as a PWA initially. So when it's installed, it looks like any other app in the system. You can make it offline capable with different techniques, such as service workers, cache, storage, and many others. And you can have a lot of capabilities to access sensors, hardware, the system. You can connect, you can integrate with the operating system. You can use Face ID, you can use the passkeys, like biometric authentication, and many other stuff directly just using plain JavaScript. You don't need to find an Angular module or an schematic that will do that for me. It's just the browser doing that. So you just need to learn how the API looks like and just call the API. And if you find an Angular schematic or a React plugin that is doing that, they are calling the browser APIs behind the scenes. like using Bluetooth or web NFC. How many of you have heard about baseline? Okay, 2. Also, this is not the first time that I'm hearing this question in the same room. There were other speakers asking the same thing. And it's interesting that typically it's 1, 2, or no one that knows about baseline. Baseline have been with us for almost 2 years now, and it's a multi-vendor effort. So it's not something from Google or from Apple or from Firefox. It's a multi-vendor effort that you should know about it. That it's kind of versioning the web features. So every year we have a list of features that are the baseline on that year. That means that every browser, every major browser at least, in that year are implementing all these features. They're working together to keep it simple. And now VS Code, they announced that yesterday at Google I/O, VS Code will, instead of right now when you are writing HTML or JavaScript, it shows you the compatibility by browser. It says, oh, Chrome from version 130 supports this, or Firefox from, well, they will remove that, and they will just say, this feature is baseline 2023. This feature is baseline 2025. So it's kind of ES versions, but from HTML, CSS, and JavaScript abilities. This is to simplify our life. So now you can go and see the list of features that were announced for baseline 2025, and that means that from this year, it's safe to use those features because they are stable in every major browser. Okay, that's kind of the idea. So, and you can see a list of features. So for example, the one that I mentioned before to make carousels just with CSS, it may be baseline 2026. It's not there yet, so it's on Chrome only. But so all the browsers are working together to every new feature that they expose to the community will be available as soon as possible on the rest of the browsers and probably on the next year's baseline version. Okay? This is to simplify our life. Okay, so I'm going to get out of here. And I just want to show you, as I promised, that I do have the source code of this app. First, you can see that every time I'm changing here, I am changing the URL. I can go back with a nice animation. And if you pay attention here to the cart, when I'm adding to the cart, you see a badge there that also works from the home page. So the badge is being updated accordingly. And that's using Reactivity. So if I'm changing the cart, that thing is being updated no matter where I'm changing the cart from. So you just change the array, and automatically you will see the badge being updated. Okay. This is again this open source. Here I have the code. I will share the URL with you in a second anyway. But there is no React. You see components. For example, I have a details page. It's a JavaScript file extending from HTML element with a DOM shadow that is taking a template and cloning it. So then you can actually go to the HTML and find the details page template. That is just semantic HTML. That then using JavaScript, I'm filling the gaps using JavaScript. Okay, so these are just web components, nothing else. You can see the router here. So it's a plain object that based on the URL, yeah, this is hard-coded, but you can quickly, easily create a JSON or something with your routes on one side and make it more straightforward. But this is just for understanding the technology behind to see that it's actually pretty simple. Also, you can see here that we are reading for history changes with pop state. Okay, so it's actually pretty straightforward, nothing really, really complicated. So, in fact, I'm not sure how many of you were doing web apps in 2007. But this is Steve Jobs in WWDC with one last thing. And he was talking about how to create apps for the iPhone for the first time. There were no App Store, no SDK. And initially, it was an innovative new way to create applications for a mobile device. And it was just the web. We were using the Ajax term. that integrated with iPhone services, instant distribution, easy to update, okay? And he was just presenting how you will develop apps for the iPhone, no SDK required, okay? That was before the App Store business, before that. And he created, in fact, part of, right now we could argue that we are using HTML5. We don't use that term anymore, but we are using vanilla web. And one big pusher of that was Steve Jobs that said no to Flash. And they implemented in the first Safari for iPhone browser a lot of JavaScript features that now are part of the idea of a PWA. Actually, the PWA, the installable web app, was created by Apple, not by Google. Google just cloned the idea, and it, of course, it injected a lot of features when Apple abandoned the idea. But it was actually come from Steve Jobs. So going back to the original list of main fears. So client-side routing is pretty straightforward. I don't see how that's a problem, to be honest. To propose, it's up to you. So if you want to use functions to create components instead of classes, you can quickly create a micro library with 15 lines of JavaScript that will let you make it that way. So it's not really a problem. So it's up to you. If you're using design patterns, you're creating your own functions that reduce that verbosity when you think it's needed. State management, and by the way, in the AI world, I think no one cares about verbosity anymore. So when you look at AI apps, okay, it's thousands of lines of code that no human will ever read. Anyway, state management, for example, using proxies, it's actually pretty straightforward. It's not really so complicated. Templating, I mean, it's okay. It's more basic than templating engines. I mean, you don't have a for like you have in ng4 or the new for syntax in Angular, but you can make it work with a template engine, and you can create your own template engine as well, or you can use JSX. Reusable components, we have pretty much a very similar power to the one that we have on libraries these days. You have to understand these three specs, these three APIs, and it will work. Learning Cube is actually pretty simple. So it's not so scary. It's not really assembler for the web. Okay, you just have to try once and understand, okay, what can you do with that? Maybe where the limits, where you feel like a better architecture. So frameworks such as Angular, they're forcing you into one specific architecture with a list of design patterns, with dependency injection and blah, 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 blah. Well, maybe you need that. Maybe you need just some parts of that, and you can implement those design patterns also with vanilla JavaScript. So the idea is for you to add a new tool in your toolbox and now say, okay, we'll see on every project, instead of just starting with your favorite language, decide on every project. Reinventing the wheel is also up to you, actually. Again, if you create your own micro library or framework, no. So lesson from the old guy. Not everything is a nail, okay? And try to have more tools in your toolbox, not just a hammer. So not everything is a nail. Take good ideas from your libraries and frameworks. If you like some ideas, you can implement those ideas and design patterns as well. This is painful, but true. Developer experience is not #1 priority. So you're doing stuff for your users because your user somehow is giving you conversion rates to you or your company, money or whatever. So but you're working for your users and for your users to convert more, whatever they're doing. If it's a corporate app, they're working faster or things like that. That will make more money for the company, and that's your goal. It's important to have a better developer experience and a good one, yes, but it's not #1 priority. So avoid tech fandom. No, I'm a Angular. I will never get out of Angular. It depends, actually. Or Angular or whatever, right? So be a professional person, and it doesn't matter. And using the latest libraries and trends are actually not goals. So, oh, we are going to start a new project. Oh, it must be in Astro because I read an article or I went to a conference and they told me that I use. That's not the goal. Okay, so check your needs and see what each library, each tool in your toolbox is offering to you, and pick the one that fits better. Okay, so don't follow trends. What are your goals? A good user experience, accessibility, high performance. This is one of the most important ones because it's the one that leads to not just money. Money cost saving is important for the company, but also more conversion. A good software architecture. Yes, we need that. We need to maintain this, or at least we need to create software now for AIs. We'll maintain that in the future when we're all dead, wherever. But we need software architecture. And your users, those are your goals. Okay? Makes sense? As I promised, here you have the GitHub URL for the project. And also you have, if you want to build this step by step, learning the process, you have some instructions to do that. So following that as a course. And also if you want a video version of that on frontendmasters.com, you have a course, like a video course, where we build this from scratch, this project, explaining step by step how to make a vanilla web application. Okay? Well, after that, thank you.